general arrangement, GA, and baseplate design for compressor packages. Intro. Welcome back to 3D Decode. Today we'll cover an essential topic in compressor package engineering, general arrangement and baseplate design. This is one of the most common subjects in interviews and a key skill for any package design engineer. Let's get started. What is a GA drawing? A GA, or general arrangement drawing, is the backbone of package design. It typically shows top view, side view, and end view of the compressor package. The compressor, driver, motor or turbine, baseplate, piping, lube oil system, seal system, and auxiliaries. It is mainly used for client approval, interference checks, maintenance accessibility, installation reference. Major components in a compressor package. In a GA drawing, the major components you'll see include compressor, API 6117 machine, driver, motor, steam turbine, or gas turbine, baseplate or skid, the steel structure that supports everything, coupling and guard, connecting driver to compressor, lube oil system, API 614, with coolers, filters, pumps, and reservoir, seal gas system, API 692, for dry gas seals, piping and instrumentation, suction and discharge nozzles, drains, vents, auxiliaries, oil mist eliminator, junction boxes, coolers, access and lifting provisions, ladders, walkways, lifting lugs, baseplate skid design. Now let's talk about the baseplate itself. Its purpose is to provide rigid, vibration-free support. Design standards, API 617 and API 686. Key features include structural steel frame with deep beams, grouted into the foundation, machined pads for compressor and driver mounting, drainage slope towards sump, lifting points for transport. GA layout considerations, interview points. When preparing or reviewing GA drawings, engineers focus on driver-driven alignment. Shaft center lines must match. API allows max misalignment of about 0.5 millimeters. Maintenance space. Clearance must be left for rotor pull, bearing replacement, and coupling removal. Piping nozzle orientation. Suction and discharge nozzles must align with plant piping. Safety and ergonomics. Operator access ladders, panels, and safe working areas. Auxiliary placement. For example, LOS tank at the skid side and seal panel accessible at the operator side. Typical GA drawing views. In practice, GA drawings are usually shown as plan view, top view, skid outline, equipment, piping orientation, elevation view, side view, shaft centerline height, piping clearance, end view, driver to compressor connection and lateral auxiliaries. Mini quiz. Let's test your knowledge with a quick quiz. 1. What is the main purpose of a GA drawing? 2. Which API standard covers installation practices and baseplate alignment? 3. Why is maintenance clearance important in GA design? 4. Name 2 typical auxiliaries shown in a compressor package GA. Practical task. Finally, here's a quick exercise for you. Sketch a simple GA drawing, top view, on paper with compressor, driver, motor or turbine, coupling and guard, baseplate outline, lube oil system at the side, seal gas panel near the compressor end. This sketching habit is extremely useful in interviews. You may be asked to draw a layout on the spot. Interview Q&A, Day 7. Here are some typical interview-style questions. Q. What is the role of the baseplate in a compressor package? It provides rigid support, minimizes vibrations, ensures alignment, and allows transport and installation. Why is shaft centerline alignment important? Misalignment increases vibration, damages couplings, and reduces bearing life. How is accessibility considered in GA drawings? A. By leaving clear space for rotor removal, coupling disassembly, and walkways. What are the main auxiliaries located on or near the compressor skid? Lube oil system, seal gas system, coolers, filters, oil mist eliminator. What's the difference between plan view and elevation view? Plan view is top-down, elevation shows height and clearances. Outro. And that wraps up today's session on GA and baseplate design for compressor packages. If you enjoyed this breakdown, don't forget to like, share, and subscribe to 3D Decode for more engineering deep dives. See you in the next video.